and welcome to the third episode of Psyche Sci on the Fly. I hope you all had a wonderful break, but now it's time to get right back to it. Hopefully, our series are relieving a bit of that midterm stress coming up as quickly as you know it. Today, we're going to be facing a different topic, not too often seen in class, but still incredibly relevant and interesting: pain. And who better to help us with this topic than Professor Mathieu Roy, an associate professor of psychology at McGill, having studied in research in behavioral neuroscience, cognitive neuroscience, and clinical work. His lab focuses on the subjective experience of pain, which we will explore right here and right now. You have most likely had him as professor, whether in perception or history of psych. Professor Roy, thank you very much for giving us a hand with this.
Thanks, Kaden. Thanks for inviting me.
Of course. So, just give us an idea of your lab. So, like going into your lab, what kind of imaging techniques do you use, and how exactly do they help you?
So my lab focuses on pain perception. And so I could describe my lab a little bit like a dungeon. So we have all sorts of tools to induce pain. We mostly use thermal stimulations. So we have a machine called a thermode that we can accurately control to induce a sensation of pain that resembles that of like holding a very hot cup of coffee just for a few more seconds, just before putting it on a countertop in order to not drop it on the floor. So we have that. Sometimes we use electric shocks that, of course, we calibrate to be, painful but still tolerable. We can use ice water to produce pain. So that's what we do. And in general, we're interested in understanding how different types of non-pharmacological approaches to treat pain work. So we look at the effects of music on pain, the effects of distraction, what happens when someone does something that they're very passionate about. For instance, we study chess players playing chess. In terms of brain imaging modalities, the main one that I used is fMRI, functional magnetic resonance imaging. So all of these experiments that we pilot in the lab, we can also perform in the scanner. We also have an EEG system, so some of our experiments also involved electroencephalography.
Well, I was wondering if you could just, for those who don't know, give us a bit of insight of what exactly fMRI is actually measuring.
Yeah. So fMRI measures what's called the blood oxygenation level dependent response. So in short, it's measuring the influx of oxygen in the brain after a certain region of your brain has been working hard. So whenever you use a part of your brain, right after the neurons have been activated, there is an influx of oxygen, and this is what fMRI measures.
Because it's really interesting because I think I actually participated in one of your more recent studies. I'm quite an avid chess player myself, and I saw this study and I thought it's for me. I have to do it, and it definitely did play a role. I actually noticed myself like playing the chess and like getting thermal shocks. I was less likely to notice it. So I'm just wondering. I know you said for a non-pharmacological treatment, but is that working at all?
Yeah, so the more general question is how the subjective experience of pain is related to brain activity. So we know that, logically, pain has to be a subjective experience that is produced by patterns of brain activity. And the hope is that with these types of approaches, we can alter the patterns of brain activity that give rise to the sensation. So distraction is very powerful, especially if one is very much engaged in what they're doing. So, for instance, with chess, we tried to go as far as we could with finding an activity that people really enjoy and care about. That's of course for more expert or passionate chess players like you. In the case of that project, what we've observed is that there is a certain level of difficulty that's optimal. So the chess puzzles that you were playing needed to be difficult, but not too difficult. So there is a sweet spot. And we think that this is related to the phenomenon of flow. So people experience flow or being in the zone when they're performing an activity that is, on one hand quite challenging, but on the other hand, that they're quite good at. So chess is a good example of that. We were also interested in the concept of passion. So there is a psychologist at UQAM, Robert Vallerand, who developed this concept, and he has a dualistic model of passion. So for him, there's harmonious passion. So when passion is there's an equilibrium between your passion and the other aspects of your life. But he also found that for certain individuals, passion can be obsessive. So that's when the passionate activity sort of like takes a hold of your life. So what we found was that the more difficult chess puzzles that were designed to be unsolvable um, reduced pain in people who had an harmonious passion for chess, but tended to increase it for those who had a more obsessive passion and who really didn't want to lose or experience failure as they played chess. So by bringing these kinds of questions into the lab, we can really carefully manipulate all of those different aspects of the tasks to understand how it's working and eventually bring it back to the clinic.
That's really, really interesting. Yeah, I know. I definitely feel that feeling sometimes when I'm playing chess. Like I have to win, I have to win, I have to win. But yeah, I'm sure that's really present in other people.
So, something that you've summarized in your research, one question is, why does sometimes pain seem to endure despite the absence of peripheral injury? And what that reminded me of is something that I'm sure a lot of students who have been in at least one introductory psych course, are also maybe thinking of and they've heard of, which is like the concept of ghost limbs and like a feeling of something still being there and there still being sensations, even though like maybe you lost a leg. So I wondered if you had any insight about that.
So I don't study phantom limb pain myself, but it is one of the good examples of a case of pain that is unrelated to peripheral injury or to the influx of nociceptive inputs from the periphery. The region of the somatosensory cortex that is associated with the missing limb loses afferences after the imputation, and so it suddenly it stops receiving signals from the body. And what we found is happening is that the other surrounding areas begin to more or less invade that region of the brain that's been sort of like left over. And the degree to which that happens will predict the intensity of the phantom sensations that people experience. And in terms of therapy, it seems that whatever you can do to make the brain believe that the limb is still there will have an impact on the phantom sensation. So the use of the prosthesis will tend to reduce the phantom sensations. Some people also use a mirror therapy. So using a mirror, you can show or make the brain of the person believe that the limb is still there. And this has been shown to have some impact on phantom sensations.
So you also mention in your summaries that you are focused on expectations in the sensation of pain. So even if this isn't something you directly study, based on your knowledge, do you think that sometimes like the cognitive expectation of feeling pain or sensing pain causes someone with a phantom limb to experience that? Like maybe if they had post-traumatic stress and we're having some sort of episode?
Yeah, so well, I study expectations. under the more general rubric of placebo effects. So placebo is believing that something's going to be less painful than it would normally be. There's also the opposite effect, which is called the nocebo effect. So thinking that something is going to be more painful than it actually is. If you believe that you've received a successful drug that will treat your pain, you'll be more relaxed, you'll feel good. And so when the pain arrives, you're already in a good mood because you think you have received medication, and you'll be less focused on monitoring your sensations. So that also reduces pain. And of course, the opposite, as you suggest, would increase pain. So if you're in a hyper alert state, like people with post-traumatic stress disorder maybe, this could increase your sensation of pain. There is an exception though. So if you're really, really stressed, this will reduce your pain. So that's called stress-induced analgesia. And it's a reaction that we think has evolved to help people cope with extreme situations. A kind of like fight or flight response. Your pain will be inhibited in those situations.
Yeah, I've actually felt that myself a couple times, and like I remember one time I was like falling off a boat and I like scraped my knee very, very badly, but I just didn't notice because I was just stressed in the moment. It was like it's like a rush and adrenaline, and I think it's like your body saying like we haven't got time to focus on that. Like let's focus on like what's going on right now. So it's pretty amazing how that works.
Unfortunately, the ethics board won't allow me to study that in
yeah, that seems a little unethical, unfortunately. So yeah, that's all the questions we really had about the lab. Like super interesting responses. Yeah, so yeah, just to finish it off, what would you recommend to someone hoping to study psychological science in your field? And could you give us a little insight of what exactly you did in our position as undergraduate students?
Yeah, so I started as a research assistant in a lab. So I knocked on a few doors, and in retrospective, I was extremely lucky to have been hired by Isabelle Peretz. So I had a general interest in emotions at large. And when I was doing my undergraduate degree at University of Montreal, Isabelle Peretz was one of the only profs who were really studying emotions through the lens of musical emotions. Yeah, so I got hired there. But this is research that really truly mattered for me. And I guess one of the key things is once you're there, right, you have to show that you really want to be there. So I would be asking for like, what should I read? I would be constantly engaging in conversations with the students, just showing that, you're there for real. And yeah. And gradually she entrusted me with more and more projects. So yeah, so if I had advice for students is try to get in the lab. I know that's not necessarily easy, and a lot of you are trying to knock on doors to get into different labs. But yeah, so either by maybe starting by volunteering, see if it's working out, or through a supervised research courses, like the honors, or there are also other courses that people can take. Or first you start with a little bit of volunteering that, if it goes well, can transition to a supervised research course. There are still many options, I think, in the departments for that.
Thank you, Professor, for joining us today. For those listening, hopefully you learned something that might help you in your classes or make your midterms a little less painful. If you're interested, we've left a link in the description to Professor Roy's labs that you can see what him and his team are working on. Thanks for tuning into this episode, and we'll see you in the next one.